Hello YouTubers, this video is a bit continuation of previous video, deeper investigation of object surface area property to absorb and emit electromagnetic waves. We start from theory of color and initial conditions, Stefan-Boltzmann law of black body radiation equation, where epsilon is emissivity dash absorption coefficient. For black surface value is 1, to mirror surface 0. This video claim is that same surface area, same material metal object in different conditions have different surface area. It means that initial epsilon coefficient will be a known value. Only range of change is well defined. My premise will be that red metal plate has bigger surface area than completely polished surface area, and vice versa. To make more clear, we compare equal surface area of new shining carbon steel sheet with reddish color same metal sheet after process of corrosion. My claim is that after corrosion roughness of surface increases, and emissivity and absorption increases also, caused by surface area increase. Causality of claim is that area and coefficient epsilon are both linked and in my view is one value. To calculate corrosion process increased surface area is difficult. We will try to solve geometrical figures of two isosceles cones, which initial surface area calculation is well known from school math class. Before calculation of surface area, I present here short theory of color. Color of object defined by property to reflect some electromagnetic waves and our spectrum of visible light to absorb. In picture, object is red, as from transparent one single ray of light, 6 light waves are absorbed, but red light not. To eye reaching red light, we can define that this object is red color. Most important, that transparent light is not white, but transparent light is crystal clear, like window glass. Office paper is bright gray color, not white. Object which reflects all light called mirror. An object which absorbs all visible light called black object. By definition, mirror can reflect transparent light, where a clear transparent glass and water media can allow light go through. Our terminology are sum of light wave spectrum. Yes, mathematical terminology of summation, not mix of 7 colors. Sum of 7 colors gives visible transparent light, which this phenomenon can be explained by that fact that all 7 colors is darker than one transparent light. So the only explanation left is that math summation of 7 dark colors gives one completely clear transparent light, and all 7 colors waves is in one phase. If 7 color is not absorbed, but not in one phase, it gives light dispersion effect or rainbow effect, when light goes through transparent media, water or glass and projected on screen. Other very important property of light is light scattering. But in this case we will use not single ray of light, but beam of light consisting of 10 light rays parallel to each other. Beam of light projected onto curved surface, as we see in picture, reflects all light rays, only not parallel to each other, but scattered by angle theta. Curved image lit by light source can reflect back not equal amount of light. This effect of shadows between light, bright and dark gives impression of three-dimensional object depth. Our light property in contact with surface is glossiness. One way of glossiness can be achieved by surface coating with transparent or semi-transparent organic varnishes. Example of glossiness in pop culture is black Darth Vader helmet from first movie New Hope, which is not glossy and shiny, and to next installment helmet becomes very shiny. My video will be focused primarily on plain metal surfaces without any additional coating. Last property and most important to this video is light energy absorption. As evidence, object temperature increase after sun rays hit surface. In picture we see that beam of light have 10 light rays, but after reflection from gray surface, 4 light rays were absorbed by surface. This absorption is main goal of this video. Opposite to absorption is hot body emission of electromagnetic waves. But this video about metals property to absorb and emit electromagnetic waves and visible light. No organic chemistry involved and answers why red paint is red. Rough surfaces have jaded relief. When light beam hits this surface, 2 light rays are reflected and scattered into random direction, but 80% of light in this case are absorbed by rigid metal object surface, and this rough jaded surface are bigger compared to plain flat surface area. This metallic mirror property to reflect well electromagnetic waves is used to shield flammable fluids from overheating and direct sun rays. Black surface area property to well absorb energy is used to harness sun energy by painting black water heater panels. We will compare two equal volume identical geometrical shape figures. First is metallic, will have small initial area, and second, same geometrical figure with bigger surface area. Like in this example, before and after metal micro-polishing processes. Abstract mathematical equation of these two identical objects are: by decreasing initial geometrical surface area, by micro-polishing or somehow increasing surface area by painting, emissivity-absorption coefficient also changes, but volume of figures stays constant. Okay, I know that sounds impossible task, but mathematically it can be achieved, and it is beautiful. To get equal volume but different surface area cone, we will use method of iteration. First iteration will be ball in size cylinder, and in every iteration step, cylinder height and radius will become 2 times smaller, and at the same time, quantity of smaller cylinders will increase 2 times. When iteration number approaching infinity, we will get 2 symmetrical isosceles cones inside sphere. First, we will solve stepping cones symbolically, made of 5 steps, and last iteration number will approach infinity. Top U of 5 circles, total area equal to. This math sequence can be written as math series equation to every integer number. Math series to every real number can be expressed as polynomial equation. To every 5 steps and infinity n steps, top area of stepping cone equal to. Top and bottom cones asymmetrical, so we multiply by 2 to find total surface area. We will solve symbolically side surface area of cylinders with constant height h and 5 various diameters. This math sequence can be written as math series equation to every integer number. Math series to every real number can be expressed as polynomial equation. In case of top and bottom area where equation to 5 steps and infinity steps are always equals, in case of side surface area, to get cone side area, we calculate math limit when n approaching infinity. Top and bottom cones are symmetrical, so we multiply by 2 to find total side surface area of cones. Total area of top, bottom and both sides of cones when n approaching infinity equals 2. As we know from school math class, two identical isosceles cones surface area equals 2. Two isosceles stepping cones and two isosceles cones side surface area in proportions equals 2. Stepping cones have square root of 2 times bigger surface area than completely flat regular surface cones, but volume of both geometrical figures are equal, and here is proof. As we know, half cylinder n equals 1 volume equal 2. And in the end, stepping cone when n approaching infinity must be equal to cone volume equation. First, when step number equals to 5, math sequence equals 2. This math sequence can be written as math series to every integer n number. Math series to every real number n we can express as polynomial equation. When n approaching infinity, we calculate limit, which equals 2. Top and bottom cones are equal, so multiply volume by 2 and get two regular isosceles cones volume. We get that isosceles stepping cone volume equal to regular isosceles cone volume. Surface area of stepping cone is square root of 2 times bigger than regular cone. To see if regular and stepping cones have different color when are made from same metal, we compare two identical regular steel cones. Only one a stepping cone when iteration have 320 steps. I know that is 3D computer simulation and artificial lighting of figures who give sensation of a natural image, and still, even to computer 3D model simulation, 320 times iterated stepping cone looks darker gray or looks like a painted with darker gray paints than regular surface cone. To me, most amazing area and volume property have Koch snowflake, which is fractal geometry example. When iteration number n approaching infinity, cross-section area of Koch snowflake approaching finite result. Perimeter of Koch snowflake when n approaching infinity increases 4/3 times more from previous result and not converges to finite result but approaching infinity. Extruded figure or of such perimeter with any height h will have infinite surface area. This property have practical application. Example, to increase air filters operation time, engineers make cylindrical air filter surface area bigger as possible by increasing filter sides triangle-shaped edges number. After a long period of operation time, filter gathers enough dust and becomes clogged. On other hand, a hollow shell snowflake Koch filter have infinite surface area, so one filter will operate forever and never will be clogged with dust. So abstract mathematics have and useful applicable properties in real life. Of course, still in very theoretical level. That is all, folks. Thanks for watching. Please subscribe.